same thing. What they're saying is here's a pressure here, here's a pressure here.
Yeah.
What's the difference?
Subtract.
That's all they're asking. What's the difference? So 2992 minus 18.2 is going to give you the answer. Should give you the answer, which is number 7. Yeah, 11.72.
So when they're using the same conversion rates like that, like they're both in inches in mercury, you would subtract them.
Well, you can't make that statement.
No.
They're asking for something about pressures,
Okay.
and they're asking about it in the same unit. Now, what they ask depends. What they ask is going to determine whether you add, subtract, multiply, or divide.
Yes, sir.
In this case, they just want to know what's the absolute pressure. You've got a pressure here, you've got there. You know, what's how could we? And what is the absolute vacuum pressure in the line?
We do have a
Think of-
module of absolute pressure, right? Listed there.
Okay, what?
And we have a module 1.4.1 that talks just about absolute pressure, so it might be listed.
You might want to read up on that.
Yes,
But in this case, they're just asking the difference.
Thank you.
Should we move on from that one?
Yes, sir.
Am I taking too long?
No, you're good.
I could do math all day. I had the class from year to year would talk about me because we'd be doing math and I'd say, "Isn't this fun?" And they said, "Mr. Becker, you have a different concept of what fun is than most people." But I think so. Anyway, temperature 20 degrees C equal to what temperature on the Fahrenheit scale? Okay, you definitely need a conversion for that, right? Why? Because first of all, centigrade starts at 0 with the boiling point of water, and then it goes up to 100 for the boiling. That's the freezing. That's the boiling. Fahrenheit uses a different size degree, and it starts at a different place. 0 is at a different place. Boiling is at 212. You can see that, you know, you've got big difference there. So you need your formula. And the formula is, and this should be the same everywhere, Fahrenheit equals C, that's centigrade, times 9/5
Which is 1.8.
plus 32. I'll put this in parentheses. Okay, order of operations, what do you do first? You got to multiply these and then add that. And you'll get the
Remind
answer.
them of the order of operations.
Yeah, and we're getting to that in a minute because one of the questions is order of operation. Okay, but you're always going to do the multiplication and division first. Okay. So in this case, what do we do? Well, there's only one variable there and they gave us that. They gave us 20. Yeah. Where's it at? Oh, this number 8.
9 divided by 5 is 1.8 times 20 is. The answer is 68.
Does everybody see where he's getting C?
C is given to you in the book. It says a temperature of 20 degrees C. So where C is, you're going to put in 20. Now, one thing to know is you can do these in any order. Okay, for some people it's easier to take 20 times 9 and then divide that by 5. Okay, you could divide 20 by 5 and then multiply it by 9. Any which way you want to do it. Probably the easiest on your calculator is just punch in 9 divided by 5 times 20 plus 32. Should give you the answer. And the answer was what?
68.
68.
I found it's a little different. I don't ever list it, but you can just, I wouldn't say assume, but 9 divided by 5 is 1.8. So could it technically always be in the parentheses, just 1.8 times the Celsius?
That's how I always put it.
Yeah.
And then for Fahrenheit, it's 0.55.
Or 1.8, the reciprocal is gonna be 55. Yeah, that'll work too.
Thank you.
So I have to ask here, right now, on centigrade, what happens at 0 degrees centigrade?
Free.
Absolute zero.
No, absolute zero, it's way down here somewhere. 0 degrees centigrade, somebody said,
Freezing.
water freezes.
Water from.
Water freezes. Water freezes. On the Fahrenheit scale,
32.
water freezes at 32 degrees. So what the heck is 0 on the Fahrenheit scale? It's not absolute. Absolute is way down. It's like 400 something.
Negative 473.
More, yeah. But what is 0 on the Fahrenheit scale? Does anybody know? Salt water.
Saltwater freezing.
Salt water freezes at 0 degrees Fahrenheit. That's what the Fahrenheit scale is based on, is the freezing point of salt water. Actually, it's a special brine solution of so much, blah, blah, blah. So if you're ever up north, you know, they put salt on the road to melt it. It doesn't work when you get below 0. They stop putting out salt, they put out sand. Or if you've ever made homemade ice cream, anybody ever made homemade ice cream?
Yeah, an old machine.
Yeah, you gotta put salt in, right?
Yeah.
Because the ice, the water ice that you have, no matter how cold it is, as soon as it starts to melt, it forms that layer of water at 32 degrees. So you can't freeze something colder. You can't get it below 32 degrees. Your cream won't turn into ice cream. But if you put salt on it, then that water layer that starts to form is going to be at 0 degrees Fahrenheit, just like your freezer. You know, freeze the cream, make ice cream. There's no extra charge for these extra treatments. Okay, so we good with that one?
Yes, sir.
Try that again. We got all day, right?
Till noon.
Okay, the number 15 to the second is equal to.
225.
15 times 15.
Yeah, y'all know that. I don't know how deep they go into that with exponents, but when we get to the order of operations, that's one of the things that we do first is the exponents. It's parentheses and then exponents. So 15 squared is simply 15 times 15. There's probably a square button on your calculator, but if you're not using a lot, just multiply it by itself. Okay. Any exponent. So we ran into another exponent. Is this an exponent?
Yeah.
Right? 3 times 3 is 9 times 3 is 27, which happens to be the number of feet in a square yard. Okay. Is this an exponent?
Yeah.
It is an exponent. It's kind of the opposite of raising something to the power. Taking the root of something is an exponent. Some people don't remember that, and they get the order of operation, they run into these, and they're like, when do I do that? What's an exponent? Just like that. And by the way, normally, if there's nothing here, it's the cube root. If it's anything other than the square root, so normally it's the square root if there's nothing written. So the square root of 25 is what? 5, because 5 times 5 equals 25. But if I put something else there like a 3, what does that mean? That's the cube root. That means what number times itself 3 times will give you that number, and the answer is 3 times 3 times 3. So the cube root of 27 is 3. And you know, again, I don't know if these are the exact questions you're going to get. I hope so. If so, that's great. But if not, they could throw you some curve. All right, so we did 9, 15 squared, 15 times 15. Oh, here's order of operations. You know, when I first glanced at this, it threw me for a second. because it's part of the order of operations. Does everybody know the order of operations right off their top? Yeah.
Please excuse
P.
my dear Aunt Sarah.
E, which stands for what? Parentheses.
Exponents, multiply, divide, add, subtract.
I got it backwards, right? But did I really? Okay, another. Yeah. Hey. Ooh, I wish I could do colors. Well, I won't. Okay, parentheses, exponents. That's non-negotiable. But when you get here, remember that it's not multiply then divide. It's multiply and divide. In other words, if you're working equation left to right, you run into multiplication, do it. You run into division, do it. You run into another multiplication, do it. Okay, it's multiply and divide. And it's the same thing with addition and subtraction. These two are and. Do them both.
I never said that in school. That's the way you have it.
Yeah, and it's they don't clear. Does it matter? In most cases, it doesn't. But in some cases, it's so much easier to know that.
That makes a lot more sense.
It's so much easier to know that you could do that.
And I heard somebody say, how do you remember this? But
You
if
said,
don't remember
please
pennies,
excuse my dear Aunt Sarah.
yes.
And if you don't like that, I won't mention them, but there's a whole lot of more risque ways of remembering. So find one that'll help you in your head. Okay, so number 10 is just.
So it would be MDAS?
Yes, MDAS, multiply, divide, add, subtract. Just the last part. Please excuse my dear Aunt Sally. All right, I like this one. Given the equation, this is number 11. Did anybody have trouble with this one?
Yes.
Okay.
I don't know.
Why am I not surprised? But W equals
This is what made us throw our hands up in the air yesterday.
CE squared. Now they wrote a slash there. My advice to you when you got something like this, you got your scrap paper, right, and you're using it, use your scrap paper. Write it in a way that makes sense to you. To me, that I don't like the slash. What the slash means is simply over 2. That's what the slash means. So if you see 4/2, that simply means 4 over 2, or 4 divided by 2. It's all the same answer. Okay, 2. So that's what that means, and that's the way that I would work that equation. Now,
Solve for C.
solve for C. All they want you to do is rearrange the equation. Okay, you're not going to get a number for C because they didn't give you any number. They just want you to rearrange the variables. So we treat it just like we treat any equal equation. Let's go forward for a second, and we'll come back. If I have, I'm sure you've run into these equations, and they look something like this, where you've got, I don't know, 10 over 2 equals 4 over x. Does that look familiar to anybody at all?
10 plus years ago, yeah.
Okay, that's kind of what you need here. So the easiest thing to do is remember the rules for cross multiplication. Okay, it's like a game where you can do certain moves. Certain moves are legal and certain moves are not. The legal moves here are basically diagonal. We can move things diagonally. Why can we do that? Well, I'll go into that after if you want. But just remember that you can move things diagonally. What that means is back to black again. What that means is, well, first of all, to get x by itself, you always want the variable by itself, the designated variable. You want it by itself, and you don't want something over it. You don't want the inverse of it. So you're going to want to move that up there. And it would be 10x. You don't want the 10, right? But we can move it. We can move it down here. Right? We basically just kind of switch them. That's legal according to the rule. But then we got that 2 underneath the x. We'll move it up here. But keep the 4 where it is. So basically this is 2 times 4. There it is. By using those simple moves, I've got x equals 2 times 4 over 10. I can solve that, right? 8 divided by 10, 0.8. Does that make sense?
Yeah.
Okay. So let's go back.
So it's just flopping stuff around until it makes sense.
Exactly.
That's all it is.
But you got to follow the rule.
Gotta follow
You
it.
got to move it diagonally. Okay. Why does that work? Because what we're actually doing is we're multiplying this side by x. So they cancel out. But we got to multiply this side by x so it pops up over here. And so on and so forth.
See how it's working.
Okay. Let's go back. See how I go back. Okay, we can do the same thing with this one. Okay, it looks almost the same. If you want, we can put a 1 there. It's the same thing, right? But look, we can move things diagonally. All right, so what we got to do is get to c by itself. So move everything else out of the way. What would we do? What would we do with the e squared? I just had my equals a little out of the way, but remember the rules say you can move diagonally. We can do this. We can do this. So take the e squared and move it over here. What about the 2?
You can put it above.
Multiply w? Yeah, move it up there. Leave the w where it is, so it's 2 times w. And what does that leave over here? Just the c. Now, they decided to write it the other way, which we can do it. We can mirror image it if you want. We can say c equals
So it would be
2w
C equals 2w slash e2.
e2.
That's the simplest way I've seen it so far.
That is awesome.
That is the most simple way it's ever been explained.
Is that so the answer would be C then, on 11. It would equal
11 should be,
2w
drum roll,
by
c. Yep.
Okay, perfect.
All we've done is we've manipulated that formula, which is handy. Because what if they give you the numbers for E and for W, but they don't give you the one for C, and you want to make it easier, maybe you're going to be doing it a lot. You manipulate the formula so that now you've always got C is going to be your answer. You can just plug in the other name.
Can we do another example?
Another example? Sure.
Is there a problem in the math? Is there a sample problem in the math? If not.
Well,
Yeah,
I can,
do P equals E to E squared over R,
let me see.
and then solve for R.
Was that in your book?
That's in the book.
All right, let me write that up. So it's P equals E squared, and did they do the slash
Yeah.
thing again? R. And where
then
they
solve
ask,
for R.
solve for R. All right, let's have a look. It's kind of the same thing, right? It's P equals E squared over R. And again, you want to put a 1 there, you can.
That's the helpful one. That's- One side has 2, the other side has 1. Sometimes that stops.
Yeah,
the way from
put that line, put the 1 there.
Okay, that was perfect.
And R is what we want. So again, we can't have the thing we want on the bottom because that's the inverse. So we got to get it up on the top. So, and I drew them kind of crooked. But again, remember it's this diagonal move. So move the R up where you want.
PR.
Well, we're gonna move up there, but we don't want the P with it, right? So immediately move it the opposite direction. Just do a flip-flop. And leave the E right where it is. That's it.
That's crazy.
See what we did? We just switched these. And we can do that because the rules of the game say we can move diagonal.
Can you do another one?
That's just
How long
crazy.
can you do another one? You got it?
I've got one a little bit more complicated, but it's the same thing.
That wouldn't be bad.
You remember, we said the formula for Fahrenheit was C times 5/9 plus
You got something to say, you gotta go tell Chris.
32. What if all we wanted to do was, what if they were giving us the Fahrenheit? They're always giving us the Fahrenheit, we want C. So can we change this formula where C equals something? The answer is yes. We can do basically the same thing. We can do something like this if we want. It looks a little screwy. But I'm doing this for a certain reason, I'll show you. The first thing we gotta do, and it's a little bit backwards from order of operation. The first thing we gotta do is we gotta do something with that 32.
Isolate.
What's the opposite of adding 32?
Subtracting 30.
Subtracting 32. What we're gonna do is we're gonna subtract 32 from both sides. And what we get then is F minus 32 equals C times 5/9.
Yep, okay.
Why? Because if you add 32 and you subtract 32, what happens?
You get a 0.
Nothing. Nothing happens to it. That stays the same. So you've got that. And if you want, we can make this, instead of writing that, remember I said you could take C times 5, you could over 9, you could do all that, or you could just say, if I want to get rid of this 5 over 9, what could I do? Well, what if we multiply both sides by 9/5? We're going to get 45 over 45, which is 1. We're going to get 1C. In other words, we made it disappear. But are we done? If you do something this side, what do you got to do the other side? That's right. 5/9. You notice a little difference here? Here we're multiplying the 5/9, then we're adding 32. Here we got to get rid of the 32 first, then multiply.
It's 9/5, right? On the left.
And by the F.
By the
Yes,
F?
yes, thank you. We multiply both sides by 9. Okay, so there I was using the add, subtract, multiply, divide both sides by something. So that's exactly what we were doing with the cross multiplying. It's just the explanation of why that works. Was that good, or did I confuse people?
Makes sense.
Makes sense. So that's why the other thing works.
Little extra steps, but it does make sense.
Yeah. And we could make it into more of a 1/over thing, but it'd be kind of.
Just wonder about that.
All right. Should we move on or do one more on that?
Good.
Move on? Okay. Excuse me. Number 12. When working with a circle, pi times d equals what? Well, what's d?
Diameter.
Diameter. Let's draw a circle. Interesting thing in the circle. long ago, some smart Egyptian or whatever looked at a circle and they paced it off, or they measured around the outside of that circle. And then they measured across that circle. And they wondered, what's the relationship between that and that? Well, it turns out that this is about a little over 3 times the distance of that. If you take this and you multiply it by 3 something, you'll get this. Or if you take this divided by 3 something, you'll get that. Yeah. Yeah. So this is called the circumference, and this is the diameter. Okay? And the ratio of the circumference to the diameter, this should be a small d, is 3.14, etc. for that circle. So that worked for the Egyptian that he paced off, but if he took something the size of a cross section of a human hair and did the same thing and punched the numbers in here, you'd get the same number. If you took the earth, measured around it, measured across it, divided the one by the other, you can get the same number. So pi is what that is. We designate that number as pi. So what you have to know about a circle is that relationship. So pi, this magical number, times the diameter is going to equal what?
Circumference.
The circumference. And strangely enough, this is just what we were talking about as far as maneuvering equations. I said that C over D equals pi. Right? So we could say that C over pi equals D. Right? And so forth. You can manipulate the equation every which way. But rather than do equations, just think about the circle. If needed, draw your circle. Put the C, put the D. That's usually a small D. Circumference and diameter. That's all you need. And know that the relationship between the two is 3 times that equals that. Why are we worried about that? Are you going to be working in circular rooms or anything? Anything cyclic is going to use pi. Anything that has a repeating cycle, like AC electricity, a sine wave. It's all kinds of formula for figuring out electrical quantities that involve pi. Okay. So it's important to know that. The incoming aviation classes in the first few weeks, I'd say, what's pi? And everybody'd say 3.1416. I'd say, no, I don't want the number. I said, what is pi? Where does it come from? Did we just make it up? And nobody ever seems to come up with, it's the ratio of the circumference to the diameter for any size circle. Okay? That's what pi is. So now you know if you decide to go into aviation instead. But you'll need to know that. You'll need to know that one. Okay. Okay, so the answer was what for number 12?
Circumference.
Circumference. Circumference. Pi times the diameter. Pi is 3 something, right? 3 times the diameter is going to be the distance around. 13 is just
Less than 90.
definitions, right? You got angles, so you got that angle, you got this angle, you got this angle, and you could even say that you've got this angle. What's the
Q.
This is acute angle. It's so cute because it's small, it's tiny. And this is obtuse. You know, it's kind of obese, right? It's obtuse because it's bigger than 90 degrees. And this is just a flat. This is just a line, right? But you could call it a flat angle. So an acute angle, oh, and by the way, degrees. Okay, what are degrees? Well, going back to our friend the circle, at some point we divided this up in degrees. The story of how we got there is long, but they decided to divide it up into 360 degrees. Okay, so you've got 90 here, you've got 180, you've got 270. Of course, that's what you got on your compass, you know, east, south, west, north. Okay. So that's what they're talking about when they talk about these angles. A right angle, you go in the center of the circle, and you start here, and you open up this angle this much, that's 90 degrees. That's where the 90 degrees comes from. So anything more than that is going to be less than 90 degrees. Anything more than that is going to be more than 90 degrees. How many degrees would this one be? 180 degrees. So this one here would be, you know, it's more than 90, it's 120 or something. This one is less than 90, it could be, that's almost a 45. So you just got to, you know that much about angles to answer that one. So the answer is an acute angle has less than 90 degrees. A rhombus. Here again, you almost just have to look at your section about shapes. You know, you have squares, you have a rectangle, you have circles, you have parallelograms. A rhombus happens to be a polygon. Poly means many, right? So polygon means many sides, okay? A square is a polygon. A rectangle is a polygon. A rhombus is a special type of polygon where it's also a special type of parallelogram where all the sides are equal. So why is that? It's just the way this is just termed. It's just what we say it is. Okay. So you have to know that a rhombus is a what? Polygon. It's obviously not a cube. It's not a triangle because it has 4 sides. It's not a circle. So it's a form, one of these forms, which are polygons. Big general term that takes in a whole bunch of stuff. All right. Number 15. Anybody have trouble with the last one, number 15? No? Everybody got it? Okay. Well, it says the length of something is 2 feet 10 3/4 inches. And we want decimal feet. What do they mean by decimal feet? They just mean how many feet, you know, do I have 2 feet? Do I have 2.5 feet? If it's 2.5, it'd be 2.5, right? So as an aside, we could say, okay, 2.5 feet is written in decimal. If I wrote that in feet and inches, what would it be? What's half of a foot in inches?
8/16.
No. How many inches in a foot?
12.
What's half a foot?
6.
6 inches. So if we wrote it this way, it'd be 2 feet 6 inches. See the problem? Why is there 12 inches in a foot? Who came up with that? Way back when, right?
Everybody in the kingdom.
Yeah, but we got to deal with it.
Yeah.
So be careful. If somebody says it's 2 feet 6 inches, and you think, well, I'm going to calculate that, so that's 2.6 feet. It's not. 2 feet 6 inches is 2.5 feet.
Written as a decimal.
Written as a decimal. So that's what they want us to do. They want this to convert this to 2 point something. Okay, we're going to stick with the 2 feet. That's easy, right? But what are we going to do with the 10 3/4 inches?
It's 75.
Well, that's the first step. We can easily take 3 divided by 4 and get 0.75. So now we've got 2 feet 10.75 inches. We still got feet and inches. We have to convert 10.75 inches into feet. How many inches in a foot? 12. So how many of that 12 is this? Right? All it is 10.75 divided by 12. Which is what?
0.89.
Yeah, 0.89. But remember, we're keeping the 2. So we just go right after there. 8, 9.
6.
Yeah, and they put, if you do it in your calculator, you're going to get like 5, 8, blah, blah, blah. And they just rounded it off to 0.896, because the 8, yeah. So the answer they put is 896. And that's it. 2 feet 10 3/4 inches is equal to 2.896 feet. And does it make sense? Think of it. You got 2 feet. You almost got 3 feet.
It does make a lot of sense.
You almost got 3. So that's where the 0.89 is like almost 9/10.
I think the confusing part is the fraction and people not breaking down the fraction to decimal.
Right. It's one of those tricks. And you know, you're like, oh, I have to do, so 0.75, and they put 0.75. Forget about the 10. Okay. So, again, it's units. It's one of those weird measurements where we mix units when we measure things using the old system.
Scary looking.